I'm here to make my points, as always, and I brought you 2 points, X and Y. They both live in R3, and I honestly expected that I would lose some of the audience with that, but I heard that you all like equations, so I need to disappoint you now. There are not many more equations, not because I don't like them, but it's incredibly hard to put them into PowerPoint. So I decided taking pictures is much easier. So here is a red point and blue point. And your task for the next 3-4 slides is just to locate those points. Okay? So very easy task. And those 2 points, locate them in this image. Okay? And you should all be able to do it. And computer scientists are very creative. Okay? So I give these points names. And whenever we need names in computer science, it's Alice and Bob. Okay? So red is Alice and blue is Bob. And I try to not confuse it during the presentation. Okay? So your task is still to find the points, the head of Alice and the head of Bob. So this image is a little bit harder, right? Did you find the points? Okay, so you did it. Congratulations. And this is exactly one of the tasks we are sometimes trying to solve when we solve computer vision problems, okay? We try to find points in images. And if you imagine you might have an image of the same scene, but from a different perspective, you need to find those points again, okay? And if you do that, you can 3D reconstruct the scene. And that's pretty cool, and has a lot of applications, and it also has a lot of applications here in EmpkinS. Here in EmpkinS, the setting is usually a little bit different. So we are still interested in the points, but the camera is usually not moving all that much, but the people in the image are moving. So try to keep track of where Alice and Bob are located. Okay? And you can do it, right? You can tell me exactly where the points are. And that's a task that's super easy. You might be able to do that before you are able to walk. But you might be surprised how hard it is to teach a computer to do that. Okay? And that's exactly one of the things still at computer vision conferences people are trying to do. Just to try to find those points in images. So it's pretty hard. Sometimes you just don't know how to approach that. And the reason is pretty simple, because it's hard. This slide I copied from a random lecture, so I was just too lazy to make new slides. Just imagine you look at 2 different patches of the image and you have to compare them somehow. You need to do that with some cool equations, and that's the simplest possible way you could do that. Okay? That's straight out of the computer vision lecture. After that there are 10 more slides how to do it correctly. Okay? So that's the simplest way to do it, and it just usually doesn't work, especially not if you do it that way. And the reason why it doesn't work is because if you look at those 2 not Playmobil, it's Lego of course, Lego figures, we have several different challenges. So they have not much texture, right? There is no face, they just look the same basically all over the body. So if you look at the small patch of that image, it looks all the same all over. Another challenge are occlusions. So where is Bob? I think Bob was the blue one. Where is the blue point? You can all tell me, but it's not visible, right? We don't see it. So how can we find that point? We have to look at Bob in kind of a holistic way, so we have to learn much more than how to locate that single point. And then one thing that I will not cover much more in detail are like specular reflections, like those white points that you see all over the figure, and changes in illumination. That makes it even harder. And that has several different applications in EmpkinS if you would be able to find those points. So there is a very simple solution for that. You just put markers, and you have seen that in the presentation before. You just put markers on the hands, and then it's trivial to find those points. So I can basically go now because my job is done, and we have found those points, and it's done, okay? But lucky us, there are different applications, and there are people who try to hide their points. Like, for example, car manufacturers, right? They build nice, fancy new cars, and then they put them on the street, and you might see them sometimes. When you drive down to Munich, you might find one of those. And they don't want to tell you how this car will look like, right? They don't want to tell their competitors what the shape of this car is, what the cool new features are, and how the car looks like. So they want to make it hard for the human eye and also for the machine to recover the shape. But either this is a very bad idea, or what I told you before was trash, because I told you low contrast textureless image regions make it hard to do that, right? So that means high contrast textured regions make it very, very easy, right? So that's exactly what we did, and we wrote a paper about that with my highly talented PhD student Maximilian Weira, who can't be here today, sadly. And he wrote this paper, and we bought the most expensive toy car of my life with exactly that pattern, and took some pictures and tried to reconstruct that particular toy car. So the picture of the toy car is on the top left. We do the 3D reconstruction, and everything else that you see is the 3D reconstruction. And if you look in close detail, you see that we get the tiniest details of that car right. The wings in the front, they're thinner than a millimeter, and we get it perfectly reconstructed. So you couldn't do anything more stupid than what the car manufacturers are doing, okay? Just to prove that, I also bought the second most expensive toy car of my life. It's exactly the same car, just with a different pattern. So what is really hard if there are specularities, right? So a normal car, if you don't put that pattern on it, is super hard to reconstruct with computer vision techniques, because you don't find those points. They just look different from every direction, you don't find them, and that's the reconstruction you get. It's super crappy, so just don't put that pattern, okay? So you might now say, yeah, he's bluffing, we took those pictures in the lab, and that's true, we took the picture in the lab, that's what we showed in the paper. So we also contacted this Automotorsport magazine, because as you can see here, they gave us 25 pictures of that car. So spoiler, 2024, so this is how that car will look like next year. They first said they are interested, then they didn't want to print it because they earn money by showing you those L-König cars, and then the whole story would be gone and you wouldn't recognize the prototypes anymore. So, those L-König cars, I mean, that pattern is pretty disturbing if you look at it, right? So for the human eye, that's pretty hard, but for the computer, that's super easy. And so going back to EmpkinS, there are plenty of applications where we don't want to put those markers on the human, right? So I think that's Marius, is that true? And Vanessa in the front, and I honestly don't know. Johanna! Perfect. Awesome. So you can watch that video on YouTube, there is also another one later. So sometimes we don't want to put those points. And the benefit of putting those points is you can make it much, much, much more precise. And if you don't put those points, you lose a little bit of precision, but you are working very hard that we can make it just as precise as if you would put those points. And you could now ask, like, okay, if you move your body, you don't worry about those points. Latest at the face, and we heard that before, if you put points in the face, that might be very disturbing, and you might move it very differently. So there is still a reason why we are interested in tracking those points. So that's it, I made my points.